Okay, so hey guys. Alright, so hello everyone. So I'm just gonna do this once. This is for Cal 2, if you're in Cal 2. Today is your lucky day. I'm doing this literally just once because for me, Cal 2 was extremely difficult and like I'm only doing this problem for, just for the heck of it, I guess. And it's trig substitution. So, I mean, this might be a pretty long video considering that I take very long. These problems are really long, but I'll try to go as fast as I can. Or I'll try not to take too long either, but I'll try to just explain it as best I can. So we want to integrate this function here, and I know that yes, I've not made many calculus videos, but I will, and I'm on the process of doing that with Cal 1, and soon enough I'll get into Cal 2. But anyways, I'm just doing this one video for this problem, just because why not? This is the integral. We want to integrate the square root of 9 minus x squared with respect to x, or dx, the integral of the square root of 9 minus x squared dx. And we have to use trig substitution for this. Okay. So, basically, if you look at your rules, and it kind of sucks that I don't have them right next to me, but whenever you have, so basically, whenever it is of the form square root of a squared minus u squared, whenever it is of that form, then that means that u equals a sine theta. Or if we have it of the form a squared minus x squared, that means that x is going to be equal to a sine theta. That's what this is going to be equal to. We're going to use this substitution, right? And we know that a equals 3, and we know that because if we rewrite the integral of this, we can say that this is equal to the square root of the quantity 3 squared minus the quantity x quantity squared with respect to x, or dx, right? And basically, so this is x equals 3 sine theta. So we know that x over 3 equals sine theta, right? So basically, let's see, and I know this is going to be very hard. It's going to be a long video. Let's see here. So we know that x is equal to 3 sine theta. What about dx? Dx is going to be equal to cosine theta, or 3 cosine theta d theta, right? This kind of works like u substitution, right? And for integrals. So then what you're going to do is you're going to go ahead and just substitute. So you're going to say that this is equal to the integral of the square root of, let's see here. It would be, so 9, it'd be 9 minus 3 sine theta quantity squared. And dx, like we said, was 3 cosine theta d theta. Okay. So basically, so here we have the integral of the square root of 9 minus 9 sine squared theta times 3 cosine theta d theta. We can simplify this square root here. So we have the integral of the square root of the quantity 9 times 1 minus cosine squared theta, and then times 3 cosine theta d theta, okay? So then we have the integral of the square root of 9 times the square root of sine squared theta times 3 cosine theta d theta. So then we have the integral of 3 times sine theta times 3 cosine theta d theta. Okay. Oh wait, my bad. Hold on, give me 1 second. Sorry, this is supposed to be it's 1 minus sine theta. Excuse me, sine squared theta. So I was looking at it. I was like, it looks kind of weird from how I was doing it earlier. So you're gonna do the integral of the square root of 9 times the square root of cosine squared theta times 3 cosine theta d theta. So then you have the square root of 9 is just 3, and then you have the square root of cosine squared theta, that's cosine theta. I mean, I know it's absolute value, but don't consider absolute value here, okay? And then times 3 cosine theta d theta. So then we have the integral of 3 times 3 cosine squared theta d theta. So then you're going to go ahead and just put that outside, so then outside of the integral. So you have 9 times the cosine squared theta d theta. And now this is the very, very important part. So you're going to have to use this rule where they say that if you have, for example, cosine squared of u, the integral of cosine squared of u du is going to be equal to the integral of 1 plus cosine of 2u over 2 du. So then you have, this will be 9 times the integral of 1 plus cosine of 2 theta, and then it's going to be all over 2 d theta. So then you're going to split it up into 2 different integrals. So you're going to say that this is 9 times the integral of 1/2 plus cosine of 2 theta over 2 d theta, like all of this, right? Now, you're going to try to split it up again into two different integrals. So you're going to say 9 times the integral of 1/2 d theta plus, actually, hold on. It's going to be, actually, let's do it this way. So it's going to be 9 times the integral of 1/2 times 1 plus cosine of 2 theta d theta. Okay. Like this. And then you're going to go ahead and grab the 1/2 and put it outside. So it's going to be 9/2 times the integral of 1 plus cosine of 2 theta d theta. Now go ahead and take the integral of 1 plus cosine of 2 theta d theta. So basically you're going to have 9/2 times the integral of 1 d theta, and let me put some brackets here, because you're multiplying the 9/2 all the way, plus the integral of cosine of 2 theta d theta. So then you're going to say this is 9/2 And then the integral of 1 d theta is just theta, right? And then plus, and then you're going to say the integral of cosine of 2 theta d theta. So if you do it over here, this can be, you can use u substitution for this. So you have u equals 2 theta, du equals 2d theta. So that means that d theta will be du over 2. So if you do u substitution, you're going to get the integral of cosine of u du over 2, okay? And then you're going to say that this is just 1/2 times the integral of cosine of u du. So then this will be 1/2 times sine of u, which is really just 1/2 times sine of 2 theta. Now, you can simplify this. Sine of 2 theta all over 2, that's really just 2 sine theta cosine theta all over 2, which is really just sine theta cosine theta. So, in reality, we will have plus, and it's going to be, so let's see, hold on. It's going to be theta plus, and it's going to be sine theta cosine theta. So, yes. And then plus c. But remember, our integral was not in terms of, what is it called? It was not in terms of, it was not in terms of theta, it was in terms of x. So we need to go ahead and make this in terms of x. Now, using right triangle trigonometry, we can find this in terms of x, okay? The way that we do this is, if you put theta here, you can say that this is equal to, and you're gonna do, so basically you have, so they did give us the substitution of x equals 3 sine theta, or a equals, x equals 3 sine theta, or sine theta equals x over 3, right? We know that sine theta is x over 3. Now to solve for theta, we need to solve for theta because that's what one of our terms is. So we have to do the sine inverse of both sides. Sine inverse of sine theta is equal to sine inverse of x over 3. So then we have theta is equal to sine inverse of x over 3. So then that'll be, I know that, so basically it's opposite over hypotenuse, x over 3, and we want to find the third term, or the third side. So we're going to use Pythagorean theorem. So we have x squared plus b squared equals 3 squared. So we have x squared plus b squared equals 9. So then b squared is equal to 9 minus x squared. And taking the square root of both sides, we get that b is equal to the square root of 9 minus x squared. Okay, so that means we can find the other two, sine theta and cosine theta. So, let's just go ahead and rewrite this expression here. Right? So theta, again, we said theta was sine inverse of x over 3. So we're going to plug that in. We have 9/2, and then we have times, and we're going to put this as sine inverse of x over 3, plus, and then we're going to put sine theta, which we said sine theta was x over 3, times, and then we're going to put cosine theta right here. It's sine theta, cosine theta. So then cosine theta, if we look for cosine theta here on this right triangle, cosine theta is just adjacent over hypotenuse. So it's going to be the square root of 9 minus x squared all over 3. So we have times the square root of 9 minus x squared all over 3. Now, this is all of this and then plus the constant of integration c. Now, you're going to go ahead and just do 9 halves sine inverse of x over 3 plus 9x over 3 times the square root of 9 minus x squared over 3, and then plus c. And we're going to simplify it a little bit more, so we have 9 halves sine inverse of x over 3, and then we have 9x square root of 9 minus x squared over 9 plus c. We know that, oh, and it's plus, right? So we have 9 halves sine inverse of x over 3. We know that the 9 cancels out here. So we have plus x square root of 9 minus x squared plus the constant of integration c. And this, ladies and gentlemen... Oh, and actually, hold on. Give me 1 second. Oh yeah, there's something I forgot to do. So this in reality is, it's going to be 2 times 3 times 3. So basically we're going to have a 2 here. Right? That's something I forgot to do. So it's really 9x square root of 9 minus x squared over 2 times 3 times 3. So then once you do that, you have this, right? And then you're going to put it over 2. So this is your final answer. My bad. This is your final answer, ladies and gentlemen. Okay. Just so everybody knows, these problems are extremely long. This is why I'm, like, I don't know, in the future, if and when we do get to these, honestly, these take really, really long to do, and I really don't want to, like, you know, spend a lot of time, trying to, explain how to do these, because I feel like even doing them myself, it takes me a while. Excuse me. Basically, you know, this is something that I really, really struggled in when I was in Cal 2. And even today I still struggle with it. So, because sometimes I can get pretty lost, and sometimes I mess my math skills up, and etc. So don't be discouraged if you found this video very stressful. This is very hard, okay? It takes a lot of patience and a lot of practice, and you know, as long as you keep trying, and eventually you'll get it, you know. So I really hope whoever watches this video, if you want to know how to do this problem, or if you want to know how to do, like, you know, if you're looking for help on trig substitution and that's what you're doing in your calculus class, then yeah, go ahead and watch this video. I hope this video did help. You know, but yes, this was something that I really struggled in. Okay, so with that being said, guys, thank you so much for watching, and I will see you guys next time. Bye-bye.